Hello everyone, my name is Darren. In this presentation, I will demonstrate how to use Euler's method to approximate the solution of an initial value problem. First, I will explain how Euler's method works using a hand-drawn diagram. Next, I will solve the problem using Microsoft Excel. Finally, I will compare the Euler's approximation with the exact solution and calculate the approximation error. This diagram illustrates how Euler's method approximates the solution of a differential equation. We begin with the initial point x0, y0, which is given by the initial condition of the problem. At this point, the differential equation provides the gradient or slope of the curve. In general, this gradient is represented by f x0, y0. Using this gradient, we draw the tangent line at the initial point. Euler's method assumes that over a small distance, the actual solution curve behaves almost like this tangent line. Next, we move horizontally by a small step size h from x0 to x1. Since the gradient tells us how fast the value of y changes with respect to x, the estimated change in y is equal to the gradient multiplied by the step size, which is hf x0, y0. Adding this change to the original value of y0 gives the approximate value of y1. Therefore, the coordinates of the next approximate point are x1, y1. Repeating this process allows us to generate more approximate points until we reach the required value of x. This leads to the Euler formula yn plus 1 equals to yn plus hf xn yn. For this question, the gradient function is f xy bracket equals to x squared plus 2 over y. I will substitute this expression into the Euler formula to calculate each successive approximation. Now, I will use Microsoft Excel to perform Euler calculations with a step size of h equals to 0.2. Column C calculates the slope using the differential equation. Column A increases by the step size of 0.2. Column B applies Euler's formula by adding the previous y value to the step size multiplied by the slope. After obtaining the new y value, we calculate the slope again for the next iteration. After repeating the process until x equals to 1, Excel gives the approximate value y equals to 2.430454. Now I will explain the exact solution. For the solution, I multiplied both sides of the equation by y, then separated the variables. Then I integrated both sides of the equation, then multiplied it by 2. Using the initial condition y0 equals to 1, I then found this expression. In the end, I substituted y equals to 1 to find the value of 2.3805. Comparing the two answers, the Euler approximation is 2.4305, while the exact solution is approximately 2.3805. The absolute error is 0.05, giving a percentage error of about 2.1%. The error occurs because Euler's method approximates the curve using tangent lines. A smaller step size will produce a more accurate approximation. Thank you for watching my presentation.